Hello everyone, we're going to look at this binomial expansion question today. And we're going to be examining later on some very unusual, well not unusual, but not very well understood ideas about the binomial expansion that the examiners like to ask questions on. So for this one, it says use a binomial expansion to show that the square root of 1 plus 4x over 1 minus x is approximately equal to that. And this first part is worth 6 marks. Okay. Now, first of all, we're going to use the laws of indices to write it slightly differently. So we have the square root of 1 add 4x over 1 minus x, which is going to equal 1 add 4x over 1 minus x, all to the power of a half. Then we can break that down further into 1 add 4x to the half over 1 minus x to the half. Okay, and then this is the same as 1 add 4x to the power of a half multiplied by 1 minus x to the power of minus a half. So we've just used the laws of indices just to break it down. And let's deal with them both separately. Let's deal with this one first. 1 add 4x to the power of a half. Okay, perfect. So we're going to be using the year 13 version or the A2 version of the binomial expansion because we can tell because we have a negative power. So here's the formula from the formula booklet that we're going to be referring to. So let's have a look at that. That is going to go to 1 plus n times x. So that is a half times by 4x. Plus n times n minus 1 over 2 factorial times x squared, which is going to be a half times by minus a half over 2 times 1 times by 4x all squared. Okay, so that's our second term. Oh, unfortunately, we've only got to go up to as far as x squared. Well, that's nice. So that, when we evaluate that, that goes to 1 plus, that is going to go to 1 plus 2x. And then it's going to go to, let's look at the next one. That is going to be 1 minus a half minus a half. So a half times by minus a half is going to be minus a quarter. And minus a quarter divided by 2 is going to be minus 1/8. And that is going to be times by 16x squared. So we're going to have 1 plus 2x minus 2x squared. There we go. 1 add 2x minus x squared. That's perfect. Good, good, good. Now, the next one, let's look at our 1 minus x to the power of a half. So let's look at that one now. Again, using the formula, it's going to be 1 plus n times x, and that is going to be minus. So minus a half times by minus x plus minus a half times by minus 3 over 2 times 1 times by minus x all squared is going to go to 1, and that's going to go to plus a half x. So it's going to go to 1 plus a half x, and then let's see what we're going to get for the next one. This, when we evaluate this whole thing here, is going to be, I believe, 3/8. Yes, that is going to be 3/8 of x squared. Okay, perfect. So we've now got our expansion now. These are multiplied together. Now, this is quite interesting because what I like to do with when you've got a larger sort of binomial thing and you're expanding it, I like to use a grid method because I think it's more efficient. So we have got 1 add a half x plus 3/8 x squared. And then we have 1 and we have plus 2x and we have minus 2x squared. And I really like using this grid method for larger multiplications because it's just so nice and systematic way of organizing everything that you can really clearly see if you've got everything you need or whether you've missed anything. So we're just going to have 1 plus, Because I think when you basically just try and do it by inspection, it can be easier sometimes to miss a term. Whereas everything's nicely organized here, and we can see that we've got everything that we need, which is super helpful. There we go. That's going to be times by 2x, so that's going to just go to x squared. Times that by 2, that's going to go to 3/4 x cubed. Well, we're not going to need that one, so because we only got to go as far as x squared. In fact, actually, we're not going to need that one, and we're not going to need that one, because we're only required to go as far as x squared for this expansion. Okay, so we've got all the terms that we do need. So we've now got 1, and now we just collect like terms. So we're going to have 1 plus 5/2x. So that's that one, and those ones combined. And then we're going to have these three combined, and when we add those together, let's just see what we get. So we've got -2, we're adding 1, we're adding 3/8 to that. So that all comes to -5/8. -5/8 x squared plus ... And that's our part A done for 6 marks. That was a very nice 6 marks. Okay, now part B. A student substitutes x equals 1/2 into both sides of the approximation shown in A in an attempt to find an approximation for √6. Give a reason why they should not use x is equal to 1/2. Now, I cannot emphasize what an important point this is, and in my experience, this part is very poorly understood. A lot of students have a real big gap here in their knowledge. So if you'll observe, we have got 2 different expansions here. 1 plus 4x to the power of 1/2, and we've got 1 minus x to the power of -1/2. Now, the range of values for which this expansion is valid is you always look at this here. This is valid for the modulus, or the magnitude of 4x is less than 1, okay? Or the absolute value is less than 1. So therefore you divide by 4, so this is valid for x is less than 1/4, which is another way of saying that x is less than 1/4 but greater than -1/4. That's the range of values that this expansion is valid for, okay? This one is valid for, again, we look at the x, okay? So we put the magnitude there, or the absolute value there. So we've now got that this means that x is valid for less than 1 but greater than -1. Now this particular question is asking us, why should the student not use x is equal to 1/2? And the answer is because x is equal to 1/2 is outside the range of which this expansion is valid for. And remember, this combined expansion here is made by multiplying these two together. And it's really useful to know that when you have this, what actually happens is the combined expansion is only valid for the most restrictive of both of these criteria. So this one is 1/4, this one is -1/4. So in fact, our combined expansion is only working in the most restrictive of those two criteria. And we can see that x is equal to 1/2 is outside that. It's fine for this one, but it's not going to work for this one. So basically we could say that x is equal to 1/2 is outside the range of values for which both of the expansions are working, okay? That is such an important point. Let me just make another example just to illustrate exactly what I'm talking about. So let's imagine we had 2 other expansions. Let's imagine we had 1 minus 5/8x to the -6. And we say we were timesing it by 1 plus 11x, just for the sake of argument, to the -3/2. Now let's say the question says, state the range of values for which this combined expansion is valid, okay? So what we would do in this case is, we would say this one is valid for -5/8x, like that, the modulus or magnitude of that. We could times by 8 and divide by 5, so that is x would be less than 8/5, which means that x would be less than 8/5 but greater than -8/5. This one would be valid for 11x, like so, is less than 1. So therefore x the magnitude of x would be less than 1 over 11. So that one is only valid for 1 over 11 and less than minus 1 over 11. If we represent both of those on a number line, we've got here our 8 over 5, which is bigger than 1. We've got over here our 1 over 11, which is like comparatively a lot smaller. There it is. Okay. So that's there and that's there. And this is the narrowest range of values. This is the one where both expansions are working. Okay. So they could ask you, you know, let's say, so this expansion would only work for the modulus of x is less than 11. Now, I've seen them ask this. Let's say they say a student wants to use 3 different values to substitute into the expansion. Okay. Let's say they want to use x is equal to 2. Let's say they want to use x is equal to 1 over 11. And let's say they use x over 111. Okay. Now, let's say the question says, okay, which values, you know, can they use? Which values can they not use? And which one would be give the most accurate answer? Well, this one cannot be used because it's completely outside the range of values for which the expansion could be used. So we could not use x equals 2. We could use x is equal to 11. Well, actually, it's got to be less than 11. So technically, we couldn't use that one. But if it was less than 11, we could use it. Okay. Actually, we couldn't use it because it's right on the threshold of what's valid. But let's imagine if it was like, we had another one here, which was say a little bit smaller. So we had a 12th, we could use it because it's a little bit smaller. And then we've got x over 111 here. Now we can use it because it's well within the range. And actually this one would give the most accurate answer. Okay, so this one would give the most accurate answer because it's the smallest value. So I think this whole part is not very well understood by students. So first of all, we've got to remember that given 2 different binomial expansions, a combined expansion is only valid for the most restrictive of the 2 ranges that each expansion is valid for. Secondly, because a binomial expansion, the smaller the value of x, the more accurate the approximation will be. Okay, so if you're presented with a range of values and they say to you which one is going to give the most accurate approximation, it's going to be the smallest value, okay, that is within the range. So this one's the smallest of all of these values, so this would give the most accurate approximation. And then another thing that I've noticed the exam board asking recently, which I think is often throws people, is this. I'm just making up a fictitious expansion here, but let's say we had 1 minus 2x minus 4x minus 11, 4x squared minus 11x cubed minus 14x to the 4th. Okay. Now, we basically evaluate this expansion. Okay, so, and we get some number. Let's just say we end up with 0.821. Okay. Now, the question asks you now, it says, is the answer that you've got here an overestimate or an underestimate? Okay. And that question I find really confuses people, but I've seen them ask that recently. They really like that. So we've got this expansion here. We've generated the first 1, 2, 3, 4, 5 terms. It's given us the answer 0.821. And the question now says, is this answer an overestimate or an underestimate of the actual value? And the answer is this one is an overestimate. How on earth can I tell that this is an overestimate? Well, the answer is, notice that the sequence is taking something away. Every successive term is taking something away from the total. So in other words, the more terms I've got, the smaller and smaller this number is going to become. It's not going to be by much. It will just be by an ever decreasing amount. But actually, every successive term is taking something off this. So because I've only got the first 5 terms there, this answer is actually an overestimate. So just be aware of that. They seem to have been favouring asking that in, especially Edexcel, in recent exam papers. And I think that's another not very well understood idea about the binomial. Okay, last bit then. Let's finish this off. So it says, substitute x equals 1 over 11 into that to find an approximation to √6. Okay, so we've got our expansion. We're back on track with the question now. My little digressions are over. But I wanted to take time to explain those, because I know that every time I teach this, invariably students don't know those two things I've just described to you. So it's super useful to know them, and it will give you an edge if you do know them. Okay, so that is going to be minus 1 over 11. So we've substituted in our 1 over 11, and let's see what happens when I evaluate this fraction. So I'm going to have 1 add 4 over 11, and that's all over 1 minus, oops, just get that into the calculator correctly, 1 minus 1 over 11. Okay, I put that into my calculator, and my calculator's giving me that that's going to be 3 over 2. So this is the same as √3 over 2. Now, that's the left-hand side, subbing in x equals 1 over 11. We need to, let's put the approximately equal symbol. Now we need to sub in 1 over 11 to our expansion. And the expansion that we had was, let's just rewrite the expansion that we had. The expansion we had was 1 plus a half x plus 3/8 x squared. So that's going to be equal to 1 plus a half times 1 over 11 plus 3/8 times by 1 over 11 all squared. And just for the sake of our time, that ends up as being 1183 over 968 is equal to √3 over 2. Now, at this stage, what we need to do now is find a way of changing this to get a √6 out of this, okay? So let's use our laws of surds. So √3 over 2 is going to be the same as √3 over √2. I can rationalize this by multiplying the numerator and denominator by √2, which gives me √6 over 2 is approximately equal to our fraction. And there you go. From there, I can now times both sides by 2. So that just gives me that √6 is approximately equal to 1183 over 968 times by 2. And when we do that, that just halves the denominator. So √6 is approximately equal to 1183 over 484. And that is our final answer. Okay, I hope that you found that video useful. I just wanted to make that video because a couple of key points there that I know from lots of experience of teaching this question that a lot of students are very unfamiliar with. I think the binomial is one of those questions where everybody thinks, oh, I know the binomial's fine, there's no problem with the binomial. But then there are parts of it that are not very well understood, and those parts the examiners always put like little extra marks. You know, they're just, you can see we've got 4 marks for this bit here. So there's marks to be had on a topic there that a lot of students are not sure of that could give you an advantage. I hope that you found that video useful, and I'll see you in the next one.